Okay, so let me import it to the other side. I'm serious. Anybody want?
Sarah would like you to know that she's not actually paying attention. She's making breakfast.
Oh,
Oh, shut up.
wow. Sarah's kind of violent, but that's okay. You're allowed to be. Wait, am I live stream the thing, or am I live stream the thing? I'm live stream. Where am I live stream? Am I live stream correct things? Yeah, it's correct things, right?
I streamed once and it did not go well because I accidentally got my mic caught in a loop and it would just be endless feedback and it was really bad. It was just Discord though, but still.
All right. So can you guys see my screen or no?
Yes.
Okay. So this question basically you need to know how to draw a picture, and this one is on the BC exam, so make sure you know how to do it. It's actually on the AB last year too. No, I didn't ladder. So there was a camera film in progress, the Daredevil, a climbing scale of wall of skyscraper. The climb is vertical at a constant rate of 16 feet per second. So this is what I will underline. I will line the 16 feet per second per minute. And the camera is 400 feet from the base of the high. And throughout how many radian per minute, the angle changing, climber is 300 feet from the building. So this is all the information. So I'm gonna look at it. Says we're gonna assign this as H, and this is a 400. So this is a camera. So there's a camera here, and obviously there's probably some type of a Spider-Man here. It's really bad, but yeah, you get the point. I can't draw like you guys. Okay, so this thing is, look at the camera angle, it's going straight up. So I'm gonna have a triangle here, and there's a triangle here. Now, obviously, we didn't need to interpret the data, interpret the things that they give it to you. They say 400 feet, the camera is 400 feet from the base. So we got this part done. 16 feet per second, that will be a DHDT if I assign that as that. So it's positive.
This man climbs fast.
16 feet per minute. Hold on, is that fast?
Pull your body weight.
Oh, I thought he was saying seconds. Okay.
16 feet per minute. Oh yeah, I write down per minute. That's about, that's probably normal. It's probably climbing a ladder.
That's like what?
And Daredevil they can climb fast, right? So you can figure out how many feet you can climb in a second. But anyway, we want to know what a d data dt is. That's the unknown. The best thing is to set up the thing says, well, it's a 400. So you have to use this 400 because this 400 is a constant. So if something doesn't change, you have to use it because that's the best thing to use. Like a ladder doesn't change. So if a ladder is there, then you take a derivative of ladder length is going to be 0. So now we just have to figure out relationship. But obviously we have an angle here. So we have angle. So we want to know what kind of relationship. So and you want to use H. You don't want to use this at all. I won't use this at all. No use. I will just use the height and the 400. So then I will set up the ratio, the trig ratio. I'm gonna set up a trig ratio that makes sure the 400 is on the bottom, because if you set up 400 on the top, it's harder to take a derivative. So which trig function I will use here?
Tangent.
Tangent, good. So then I will do tangent of data is equal to h over 400. And I think Zach was in tutoring. He just do like h is 300 over 400, but after you take a derivative, there is no dHdt is being used. So you have to keep the h over there in order to work. And the reason why you don't want to use cotangent, because you're going to be 400 over h. It's harder to take a derivative. You don't want to use sine or cosine because you don't use dHdt. So you have to use, somehow you have to use these two things, so it has to be tangent. And you want to make sure 400 is on the bottom, because now if you take a derivative of this, you're going to get d theta dt. And that's going to be secant squared theta, d theta dt is equal to 1 over 400 and a dH dt. Any questions here? It's good. And d theta dt is equal to 1 over 400 times dH dt, which is 16. And I'm going to move secant to the other side. This becomes cosine of it, square root of theta. Because if I move to the other side, I'm divided by secant inverted, it's going to be cosine square. And that's equal to, I don't know, I can divide this by 4. So that's 400. And I can becomes 1 over 25. So 1 over 25. And then I just need to figure out the trig ratio. Cosine of theta is equal to SOHCAHTOA. So cosine theta equal to adjacent over hypotenuse. So in this case is 3, 4, 5 triangle. So it's a 4 over 5 square. So that's equal to 16 over 625 radian per minute. Most of you guys don't know what radian is. A radian is around 50. 1 radian is about 57.3 degrees. So is one. That's like a very, very minimum. I would say that's probably you can times by 57.3 degrees after you do 16 divided by 625. Let me see if I can do that in calculator. So it'll be 625, so 16 divided by 625, and times 57.3 degrees. So it's probably 1 degree, 1.5 degree change every minute. Not really fast, but I'm pretty sure the guy's climbing pretty fast. Does everybody knows what you're doing here? Now, I will definitely put this question on the test. Not this particular
Wait, Mr.
question.
Ye,
Yes.
how did you know it was the 3, 4, 5 triangle?
Okay, that's a good question. So
Because it's 300 and 400, so it's just 100 times 3, 4, 5.
yeah. So it's
Oh, I didn't see the 300, my bad.
yeah, the h is a 300, but I didn't write down there just because the h is still changing. But they want to find out the angle is changing at 300. So the way probably to write this is like write straight line when h is equal to 300. That just means that straight line just means when h is equal to that. So that way you know that h is still constantly moving up because the guy is not going to stay at 300 feet high. It's still moving up. So that's the one that you have to use a variable for that. That's why you have to use h instead of 300. Because Zach had the same problem. He thought is if you plug in 300 and try to take a derivative, but he gets nothing when you do that. You don't have a dHdt, which is you want to be able to use dHdt to help you solve the problem. So this one, 100% will be on the test. I personally love the ladder one. I just think all the ladder one. So this can be ladder is how fast the angle is changing, or bottom, or base of ladder, or the top of the ladder from with the wall. You can also ask that way too. So you can ask it so many different ways. Other questions for homework?
What if he tells like every single question that's gonna be on the test?
That'd be very cool of you. I agree.
I'm gonna tell you this question's on the test. Okay, so let's talk about the comb one. This comb one is kind of interesting. They already draw it for you. Water's pouring into 24 feet tall. So this is 24. And the diameter of the top is 20. So this is 10. So this can create a one-order relationship, which is R over H. So that's equal to 10 over 24, which is equal to 5 over 12, R over H. If that's the case, you are write down the formulas of the volume of foam in terms of H. So V equal to 1/3 pi R squared H. And then you can say R is equal to 5 over 12 H. If you do that, it's going to be 1/3 pi. R is going to be 5 over 12 H squared times H. So it'll be 1/3 pi times 25 over 36. No, over 144. H to the third. So it'll be 25 over, I don't know, 300. I don't know what's 3 times 144 is. 3 times 144 is equal to 432. In a pi H to the third. So that's using a relationship and also use similar triangle. And this is the one that is on the SAT, is they deal with this similar triangle. So you can create this relationship. And this relationship always gonna hold true. No, you had to go take it. You had to go make sure you know how to do everything.
5 children.
Okay. And then that's that. Any question about that part? Last year we talked about this, the two relationship. One relationship is similar triangle, and one relationship is volume. You can use this relationship to reduce the variables. It just change it in terms of H. Now B, just plug in when the volume of water is increasing at 3.4 cubic feet per minute, and the height of water is 2 feet. What's the rate of height is changing? So if this is 3.4, is equal to dv dt. So I'm going to take a derivative of this. So let me take a derivative of this. V is equal to 1/3 pi 25 times 144 h to the third. The reason why I keep that 1/3 there, if I take a dv dt, the 1/3 cancel out. So this is equal to just 25 over 144 pi h squared. And you can plug in, so it's 3.4 equal to 25 over 144 pi. I'm sorry, there's a dh dt as well. The h squared is going to be for dh dt. And you just flip everything over. I don't know how the evaluation of this, but I'm just going to write it down, dh dt is equal to 3.4 times 144 and over 100 pi. I think that's this, dHdt, how fast the water is changing. Any question about this part? No? Okay, so the last part says radius of surface of water. So surface of water is right here. In the tank is increasing. At what rate is area surface changing when radius of 4.2 feet? So radius of 4.2 feet is probably here. This is 4.2. And then you say, okay, well, the radius of surface of water is taking changing dRdt. I think they say the radius surface of increasing at 0.5. dRdt is 0.75 feet per minute.
Students, 1 minute remaining.
And they say what rate is area surface area changing when the radius 4.2 feet. So area is equal to pi r squared. dAdt is equal to 2 pi r dRdt. And that's just equal to 2 pi. R is going to be 4.2. And dRdt is going to be 0.75. And you can leave your answer like that. And that should be fine. What's up, Jake? Okay, so I will say the question I would definitely put on the test is the angle one for sure. And this one I'm thinking about it. I love the Conic questions. That's just how it is. Last year I put on the test as well, and I do think a ladder of this one, but it's how fast they slide down. That's good. And also this question too. I really like this question. This question is really good. I don't know if you guys did it right though. I don't know. How comfortable are your answer for number 2? What'd you guys get? Do you guys all get?
I got B.
You got B?
I got B.
Okay, let's see. B is -5.
Yeah, has to be right.
Has to be right. Okay. We'll see in a second. So they say deflating at a constant rate. The reason why this one is good is because you had to get one dRdt first to get to the other one. So a beach ball is deflating at a constant rate. So that's going to be dV dt is equal to -10. So that's this information right here. The volume is equal to 4/3 pi RQ and is equal to 25/6/3 pi. So I can get rid of 3 on both sides. So let me just set them equal to each other. And that's in order to find R. So this is going to be RQ. Pi is going to cancel out. 3 is going to cancel out. 256 divided by 4 is 64. R is equal to 3. So once you find 3, then that's good. And they say, what is the rate of changing the surface area? So they want a dSADT. We're going to say surface area is dSADT or dSDT according to this. dSDT is
Wait,
equal
how
to
far was the 3? Isn't it 4?
Oh, I can add. Thank you. I can add.
Okay.
Okay, so that's 4. So once you get to this part, then you use all the information. because they give you this part you already used. We haven't used dvdt yet. dvdt is -10, so we're going to take the v equal to 4 pi rq. dvdt is equal to 4 pi r squared drdt. And this is a -10 is equal to 4 pi. R squared is what? Because in order to find out surface area is, let's say s equal to 4 pi r squared, ds dt is equal to 8 pi r dr dt. That means I still need a dr dt. I have 8 pi, I have radius is 4, but I don't have dr dt. Once I got dr dt, I'm good. And this is how you find a dr dt. R squared is going to be, what is r squared? 4 squared, right? And dr dt. So it'd be -10 equal to 64 pi dr dt. And dr dt is what? -10 over 64 pi, I think.
Yeah.
So you're going to substitute that into here, which is -10 over 64 pi. And the pi cancel out. This will be left with -10 over 2, which is equal to -5. So you guys have a right answer. Good job. I thought that was actually kind of hard because you need to deal with 2 layers. So of all the questions, I like those 3. I like the one I go over, and also this one, but I don't think this one I need to go over. It's sliding down 3 over 2. I'll just go over it really quickly then. I know you guys have more time now. So this is a 15 sliding away at 2 feet per second. So this is x and y. So it'll be x squared plus y squared is equal to, I don't know, x squared plus y squared is equal to 15 squared. So now you still utilize the constant. So it'll be 2x dx dt plus 2y dy dt is equal to 0. We say how fast is sliding down. We change the question. Say we want to find out dy dt is equal to question mark. And if I already told you sliding down, you only need to look for the positive. So it'll be 2 times 9 times dx dt is 2 plus 2 y. This again is a 3, 4, 5 triangle because this x is equal to 9. This has to be 12. So it'll be 12 dy dt. Sarah John probably says, how do I know that? It's just a ratio, right? So that it will end up to be dy dt is equal to -3 over 2. But since they already told you sliding down, then it's just going to be 3 over 2 feet per second. What one other question I like? Yeah, I also like 5. I think that's all the question I'm gonna pick. I'm gonna pick all those questions. I'm gonna pick 5. Does everybody know how to? Yeah.
So how do you know when you take away the negative sign, like for the answer?
Who's this?
Zach.
Oh, okay. How do I know? Because if I would have told you, see, this question is worded wrong. This question says should be how fast the lighter sliding down. Now, if I told you sliding down, then it's sliding down at 3 over 2 feet per second. Because it's negative.
Okay.
Sliding down is actually indicate that.
All right.
Yeah. And so, but the question here is definitely worded wrong because if it's 2 feet per second, how fast the pace? That's just 2 feet per second. That's not rocket science. I like this question is that this is a triangle, but all 3 parts moving. All 3 parts moving makes it a little bit more interesting here. Do you guys know how to do number 5, or do I need to go over it? This is the last question I'm gonna go over. Don't worry. You good? Cage is good? Okay. So that means I don't need to go over this one. What do you guys get for answer anyway?
B.
Is it B?
I got C.
Wait, yeah, I got C too. I got C.
I got C.
Somebody say B? No? Okay, so C is good. Just because all three parts moving, so you might have to involve with three parts moving. But yeah, that'll be all. And thank you for coming, by the way. I'm bored in my room. Jake's not even here with me. I'm so disappointed at you, Jake.
Do we get extra credit?
Huh?
I'm so sorry. Do we get extra credit? True. Extra credit, yeah.
I told you what's on the test. How about that? I already told
We're
you.
dead.
Five extra points.
5 points? Yeah,
Yes.
why not?
Yeah, just 5.
Why not?
Let's
Yeah.
go. So he has the
Hold on. Let me
Nice.
take a picture of the list.
I'm not gonna lie, I kind of woke up like 2 minutes before the call and then like joined in. So
Yeah, Jake only came 2 points because he joined the last 2 minutes.
Yeah.
Hold on, let me take a picture of this.
Okay, period.
There you go, Hal. I don't want to give Hal extra credit.
Why not?
Hal probably is playing Minecraft right now. He's not even listening to me. Share your screen. Is that Minecraft screen? Share your screen. I was probably my Minecraft. Well, he's a League of Legends type of person. I cannot hear you, Hal.
I've never played League of Legends in my life.
Really?
Really.
You look like a League of Legends person.
And I was paying attention.
Wow. That's a lot of book in the back. Do you actually read them?
Well, like 3 of the shelves or 3.5 cookbook/dictionaries. Some of them are library books that rotate that are gotten by younger siblings. A bunch are music books. But the ones on the bottom shelf I've read.
Oh, nice. All right. I'm bored. Maybe I should get some grading done though. That'd be a perfect day to get grading done.
Yeah, you should grade our test. That's like such a good idea.
Yeah, I'm gonna do that now.
He has 2 tests he needs to grade, doesn't he?
Yeah, it's a good idea. Oh, I have a Samuel's test right in front of me on Trick. You didn't do too hot on that one.
Okay.
Yeah.
All right, take it easy, guys.
Yay. That's your day.
Bye.
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 Thank you.
No problem.
Bye.